Welcome to Math with Mrs. Seeley. Let's get started with this 2024 free response question number 6. In this question, we are given the functions f and g, given by these two expressions, as shown in this graph right here. A part says let R be the region bounded by the graphs f and g from 0 to 2. Write, but do not evaluate, an integral expression that gives the area of region R. Well, if you'll recall, if you want to find the area of a region that's bounded by two curves, remember it's the top curve minus the bottom curve. So in this case, we know that f of x is our top curve and g of x is our bottom curve. So therefore, the area is equal to the integral from 0 to 2 of the top curve, which is f of x, minus the bottom curve, which is g of x, and then don't forget your dx. If you were able to know that the area is found by the top curve minus the bottom curve, give yourself a point for knowing that it's f of x minus g of x, that integram part. Then you'll get another point for the whole answer, including having your in limits of integration, having your brackets, having your dx there. Okay, let's take a look at B part. All right, B part says, let S be the region bounded by the graph G and the x-axis from 2 to 5, as shown up here. So from 2 to 5, we got the x-axis and the curve g of x. This says that region S is the base of a solid, and this solid, the cross section is perpendicular to the x-axis, is a rectangle with the height equal to half its base. Find the volume, and we're going to show our work that leads to the answer. If you'll recall, if you want volume, you integrate area. So we need to integrate the area. The area that we're doing this time is a rectangle. And you guys are familiar that the area of a rectangle is base times height. But if you notice in this question, it says the height is equal to half its base. So therefore, the base is just what it is, the base. But this height, we're told, is half the base. So therefore, the formula for area and what we need to integrate is 1/2 base squared. So therefore, if we want the volume, we're going to integrate from 2 to 5 of 1/2 base squared. But recall, we are talking about region S. So therefore, these rectangles are going to be the function g of x. So we'll go back and we'll take our base and we'll put g of x squared. And then dx. If you got the limits of integration, give yourself a point, and you knew to do the integral. Then they give you another point for this 1/2 g of x quantity squared. All right, now let's find this answer. So we're going to have to grind this one out. We do not have a calculator. So it's the integral from 2 to 5 of 1/2. Let's put our g of x function in, which we're told up there is x squared minus 2x quantity squared dx. All right, let's come over here and let's take this right here, x squared minus 2x, and we got to write that out twice. It's a twin. You got an identical. So that's x to the 4th minus 2x to the 3rd minus 2x to the 3rd plus 4x squared. So what we're integrating then, and I'm going to pull my 1/2 out front. I just like to get those constants out there. So we're going to have x to the 4th minus 2x to the 3rd. Well, actually, we have two of them. and 2 of them, so we have 4 of those, plus 4x squared dx. All right, integrating that, we have 1/2. That would be add 1 to it, so that would be x to the 5th, but you divide by that. So 1/5 x to the 5th minus add 1 to it, which is 4, but divide by 4, and that's just going to give us x to the 4th plus add 1 to it, which is 3, but then you divide by that 3 to get 4/3 x to the 3rd dx. If you were able to integrate that, give yourself a point right there. All right, now we have to plug our 5 in and our 2 in if we're going to evaluate that. So I'm going to keep them separate. So I have my 1/2 will come over here. Now I'm going to plug my 5 in first. So that's 1/5. Put your 5 to the 5th minus 5 to the 4th plus 4/3 5 to the 3rd. Okay. Then I'm going to have minus, can put my 1/2. Now I'm going to put my 2 in. So I have 1/5, 2 to the 5th, minus 2 to the 4th, plus 4/3, 2 to the 3rd. Okay. Now what I would do here is that's 5 to the 5th, but that's a 1/5. So kind of think of it like this. If I have one of them and I have 5 of them, can I cancel and just have 5 to the 4th of them? So I have 1/2, 5 to the 4th, but I'm fixing to subtract 5 to the 4th, plus 4/3 times 5 times 5 times 5 is 125. Those are going to cancel, and so I'm just going to end up with 1/2 of, let's see, that would be 500 over 3. Okay, minus here, that's 1/2. 2 to the 5th is 32, so that's 32 over 5 minus 16. I'm going to put a 1 there just because I like to stay consistent. Plus 2 to the 3rd is 2 times 2 times 2, which is 8 times 4, which is 32 over 3. Okay, so I have 1/2. Now we need to get a common denominator right here, which would be 15. That goes in there 3 times. 3 times 32 is going to be 96. That goes in there 15. 15 times 16, go over there and do some chicken scratch, and you get 240. 3 goes in there 5 times. 5 times 32 is 160. So I'm going to have 1/2. Going to need a common denominator of 15 now. 3 goes into 15 5 times, so that's 2,500. Minus, if you do all of that and do whatever kind of scrap work you need to do, you're going to get 16 over 15. So that's 1/2. 2,500 minus 16 is going to be 2,484 over 15. I'm going to take this 2 in the bottom and cancel that and get 1, 2, 4, 2. So I have 1,242 over 15. Now divide everybody by 3. We're just going to reduce it. And you get 414 over 5. And that's your answer. You can have that or an equivalent decimal or mixed fraction, but I feel like we've done enough work. It would just be time to stop. And so if you got to that, give yourself your last point on this particular B part. All right, last part is C part. C part says to write but not evaluate an expression that gives the volume of the solid generated when region S is rotated about the horizontal line. Okay, remember we just said that volume you integrate area. The thing with when you are rotating like this these are going to be circles. So if I take this region right here, and I'm going to rotate about the line y equals 20. So we're going to take this right here, and it's going to rotate. That's going to be my outer radius or my outer curve. And this right here is going to be my inner curve. So we're going to end up with a washer. So this will be the washer method, where we're going to take the outside circle minus the inside circle. So we just said it's a washer. Whenever you're doing the washer method, recall that it's the outer radius squared minus the inner radius squared. Okay, so I will have pi, because the area of a circle is pi r squared, so pi. And then we said from 2 to 5. But now here's the next catch. When you are going about a line, your radius is adjusted, because the radius is no longer just from the to the line like a disc, but it is adjusted by the length of that line. So like this orange one, it's this right here is my radius. So it's from the curve to the line. And the same thing with this purple one. It's from the curve to that line. That's the radius. So when I'm getting my radius, it's defined to be, you can either say line minus curve, or you can say the curve minus the line. Both are acceptable. So on this right here, I'm going to give myself a little more room. The volume is going to be pi. We said we're going from 2 to 5. And so my outer radius, that was this right here. This is the outer, this purple. And that's just the x-axis right there, which is 0. So I'm going to say, I think I will just do maybe the curve minus the line. So my curve is 0 minus the line 20. That's the outer radius squared, minus the inner radius. Well, the inner radius, remember, was the function in orange, which went from g right here. So that'll be g of x. So that's that function minus the line, quantity squared. So you have outer radius squared minus inner radius squared, where your radius is the line minus the curve, or the curve minus the line. Then I'm going to get that a little bit more proper and put my d of x right there. All right, to get your points on this section, if you have the pi out front and the 2 and the 5, the limits and the pi, that gives you a point. Your integrand, if you knew to say like outer radius minus inner radius squared, and you knew to say line minus curve or curve minus line, give yourself another point. And then to get that last point, you're going to, they're looking at the whole form of the integrand. So it's like having your brackets, having your d of x. So kind of getting that whole thing, you get your last point. I hope you found this helpful in preparing for your AP exam. If you did, please like, comment, and subscribe to the channel. And be sure to check out other AP Calculus question explanations, as well as other calculus tutorial videos on the channel. See you next time.